Here in this video we'll be discussing about Newton's third law of motion. It is probably the one of the easiest law of motion stated by the Newton. Okay, so here what is Newton's third law? Says action and reactions are equal and opposite. Let's see the example here. This is the rocket. It's launched and the effluents, the when the combustible fluid are burned, and it is coming out through the nozzle with some velocity, with some force, that creating a some force. Okay, the force with which the effluent gases are coming out is equal to the force with which the body is moving, rocket body is moving. So forces are equal and opposite. See, if it is coming with a 10 Newton force, the same with the 10 Newton force, it is going in the forward direction. So in the effluent gases are going in the downward direction. This is what Newton's third law says. And one more application is in the recoiling of gun. Here what happens is, if we consider an equation, this is the mass of the bullet, initial velocity of the bullet, and the mass of the gun, initial velocity of the gun is equal to mass of the bullet, final velocity of the bullet, mass of the gun, final velocity of the gun. This is small v, this is uppercase V. So initial velocity for the gun and the bullet is 0, so this term becomes 0, this term becomes 0. Here mv plus mv is equal to 0, so mv is equal to mv negative sign. This negative sign shows the gun moving in reverse direction, moving in reverse. This is what Newton's third law. This is how the recoiling of the gun is calculated. mv plus mv is equal to 0. This is for the gun, this is for the bullet. Hope you guys understood Newton's third law of motion. It's a pretty easy concept compared to all other laws. So I think you can make the problems also. Problems are even very easy in this case. Okay, we shall see the problems in the next video. Thank you. So in this video we'll be discussing about problems on Newton's law of motion. So here is the first problem. A 1000 kg spaceship travels in the vacuum of space at a constant speed of 500 meter per second. So they have clearly mentioned the mass. The mass they have given m. The speed is given. So they have mentioned clearly constant speed. Constant speed means acceleration is equal to 0. So they want to know what is the net force acting on the body. So net force is equal to m into a. So acceleration is equal to 0 for a constant speed, and the f net becomes 0. This is the first problem. Second problem. Let's see the second problem. Okay. So a passenger in an elevator has a mass. Okay, has a mass, exerts a force of 100 Newton downwards. Okay, this is the force that is acting, okay, downwards to the elevator. He experiences normal force upward from the elevator's floor of 120 Newton. What is the direction of is accelerating, if at all, and what rate? Okay, this is the problem. So they have not given the mass, they have given the what is the downward force acting. So considering the equation F is equal to mg, the force they have clearly mentioned 100 Newton, and the mass we need to find, and the g would be 10. So x, that is mass, is equal to 10 kg. This is the first finding that we need to go. So mass has become the 10 kg. So they have given clearly mentioned this one is the downwards force. Here they have given from the elevator, the normal force from the elevator's floor is upward 120 Newton. 120 minus 100, 20 Newton force is acting in the upward direction. So considering the equation, second law of motion, from the second law of motion, second law of Newton, we can say F is equal to m into a. F net force is 20 Newton, that is upwards 20. The mass they have given 10 kg, and what is the acceleration? So A is equal to 2 meter per second square. This is the answer. So the acceleration is 2 meter per second square, and in the direction upwards. So a skydiver of mass 92 kg has reached a terminal velocity of 52 meter per second. Estimate the force of the wind resistance she is experiencing. So here they have given the mass, they have already given the terminal velocity. What is terminal velocity? Terminal velocity is nothing but a constant velocity. Okay, constant velocity implies acceleration is equal to 0. That again in turn implies the force, net force acting on the skydiver is 0. So what are the two forces again? What are the again forces experienced by the skydiver? The one is the gravitational force, and the second one is wind resistance. Okay, this is the wind resistance. So gravitational force is given by F is equal to mg, that is again equal to the wind resistance. So F is equal to mg. M is 92 kg, and so G consider 10 is equal to 920 Newton. That is the force of wind that skydiver is experiencing. So here is the second problem. Okay, two masses of 5 kg and 7 kg situated on frictionless. They have already given. The friction is neglected. Friction force. Horizontal surface that are connected by a light string. This is string, and 50 Newton force is exerted on the mass on the right to the right. So there is a 50 Newton force that is applied. Determine the acceleration of the system and the tension in the string. So A and tension we need to determine. So let's consider, since these two bodies are moving with the same acceleration, since this is connected by the string T and this is being pulled by the 50 Newton force, these two bodies are absolutely moving with the same acceleration. So we can merge these two bodies so that the mass becomes 12 kg. So considering the equation F is equal to ma, the force is 15 Newton, the mass is 12 kg, acceleration is equal to what? A is equal to 50 by 12, and here it is 50 by 12 is 4.16 meter per second square. This is the acceleration the whole system is experiencing. Some acceleration, that is 4.16. So let's consider to find, in order to determine the tension of the body, means tension in the string. So we need to consider the free body diagram. For the free body diagram, we shall see here This is it, and this is the normal force acting in the upward direction due to the weight acting downwards, and this is the weight acting in the downward direction, and this is the tension. This is for the first body, that is for the 5 kg body, and for the 7 kg body, one more free body diagram. 7 kg body, here it is the 50 Newton force, and here is again the normal reactional force. This is mg, and here is the tensional force. Let's consider for the 5 kg body. So since the acceleration for the two bodies are same, since this is closely connected, suppose if we consider a railway wagon, okay, so since the first bogie and second bogie, the all are, if any bogie is accelerated, the same acceleration is comes in the second body also. The same way, when this body is accelerated, the same acceleration is experienced by the second body. So A is nothing but equals to 4.16. So considering the T, what is the T we need to determine? Mass is 5 kg and 4.16 is the acceleration. So what is the thing? 5 into 4.16 is 20.8. The tensional force is 20.8 Newton. That is for the tension in the string. So we need to determine, we can transfer with considering the second body. So we shall consider the second body. Second body is, so 50 Newton force on the right minus T, that is equal to, is equal to mass into acceleration. Mass is 7 kg into 4.16. So resolving this equation, 50 minus, so 7 into 4.16, 29.12, 50 minus 50, 20.88. T is equal to 20.8 Newton. So since the answers are same here and here, can say the tension is 20.8 Newton and the acceleration is 4.16. I think you have got the answer. We shall be discussing further more problem in next video.